Alright. We're almost ready. Draw this picture first. It looks like this. All right, let's start. So first thing is that we're looking at number 10 from 11.1, which is this problem right here. They're asking for the radius of this, so you gotta figure out how you found this arc length, okay? Because this arc length is 38.95. So arc length formula we know has to do with the circumference, so it's 2 pi r times the ratio. Right here the ratio is 260 over 360, because that's the ratio that I'm doing. The radius I don't know, but I know the result is 38.95. Okay, so now once you get this equation, you have these numbers multiplied together, you have that, then you can solve for r. That's it. Okay, I'm not going to tell you what the answer is, but that's all you need. Once you set it up, this is a number, this is a number, this is a number, this is r, right? So you can solve for r. Okay, so that's number 10. Number 26, they're asking you to find the circumference of the circle of this. 6. So x plus 2 squared plus y minus 3 squared equals 9. That's the equation. They want you to find the circumference. The circumference is going to be, any circle is going to be 2 pi r, right? So it's important to find this radius, and that could be found in the equation. Why? Because this is the equation form, right? This is r squared, so r is 3. Okay, you just plug it in, and then you can get an answer. That's it. Okay. 30. Number 30, this is a kind of a word problem. Say over 2,000 years ago, the Greek scholar estimated Earth's circumference by assuming that sun's rays were parallel. Chose a day where sun shone straight down, and then at noon he measured the angle and assumed that the distance from both of these are, so it looks like this. I'll draw the picture. So it looks like this. I think they drew this one for you. But sunlight goes like this, okay? And then Alexandria is here. Cyan is here. And you're measuring from the center of the Earth, right? There's an angle here. So here's a stick. Okay. I'm good at drawing here. The stick is here. And they say this angle right here is 7.2 degrees. And the distance from here to here is 575 miles. Okay? They want to know how we could estimate Earth's circumference. Okay? So, first of all, because these two are parallel, right? Parallel. 7.2 degrees here indicates that this is an alternate Oh, okay, you can't see. All right, we're here. All right, let's start again. So parallel lines, they drew this picture for you, right? So 7.2 degrees here. Because they're parallel, we can say 7.2 degrees here. 575 is here, right? So same thing, this is an arc length and we want circumference, right? So keep in mind that your you don't know the radius, right? So you gotta find the radius first. So 575, so we're gonna use the arc length formula again. Arc length is equal to 2 pi r, in this case is 7.2 over 360. Okay, so 575 equals 2 pi r 7.2 over 360. From there, you can solve for r. Okay, solve for r. Once you solve for r, your circumference will be 2 pi r, right? Then you can find this. Okay, so that's 11.1. 11.2. Paper real quick. Oops. 11.2. Okay, 11.2, I'm looking at number 11. So number 11 is over here. Say a 210,000 people live in a circular region with a 12-mile radius. Find the population density in people per square mile. So a circular region, right? They tell you the radius is 12 miles. So density is equal to mass over area, right? In this population, which is total people, okay? Population. So in this case, population is this many people. And we're talking about the density per area. So you got to figure out what the area is first, okay? In this case, it's circular area, so it's going to be 12 pi r squared, right? Like that. And then you can find what density is, okay? That's all. Density is how many people per area, right? In this per area, that is what it looks like, okay? Population per area is density. Okay, that's number 11. Next one's 23, 11.2, right? So you want to look for, so 23, you're looking at kind of like a donut, right? So the donut area, they say the inner radius is 6, outer radius is 24. Then the idea is basically use the large one, subtract the small one, you can get everything in between, right? So pretty simple. Just do pi r squared minus pi r squared. Okay, it's big minus small, right? Big minus small. Then you would get the region in between. Okay, that's 23. 25 is very similar. 25 is very similar. So 25, I would do it twice. So you kind of have to break it down a little bit. I'm gonna look at, so it looks kind of like this, right? And each one, I think there's one more layer, maybe 1, 2, 3, 4, 1, 2, 3, 4, 5, one more. Okay, so they're asking for like this outer one plus this inner one, right? Two of them. So I need to break it down into finding this and then this, okay? So I'm gonna break down from the very outer. So I know they're 1 each, right? So 1, 1, 1, 1, 1, so 5, right? So the first one is, biggest one is 5, and the next biggest one is 4, right? Next biggest one's 4. So I'm going to subtract it away. Okay, so pi, the very outer one is going to be pi r squared minus pi r squared. Okay, then I'm gonna take the other one, which is I think 1, 2, 3, 3, and subtract the 2. Okay, that will give me the next one, which is pi 3 squared minus pi 2 squared. And then after you get both of them, you add them up. Okay, once you add them up, you get an answer. Okay, so this looks complicated, but I can break it down into different problems. Like, I ignore everything inside, I just look at the outer ring, and then ignore everything outside, just look at the outer ring from here, as if these don't exist, just the inside part. And then I add them together. Okay, there's two different rings. The last one is 27. Right, 27. So 27 is a circle plus a triangle. They tell you this is a 90 degree, and this is the center, right? And then this is 5 inches. Okay, so first of all, you gotta find the radius first, because you want to find the shaded region here, right? So you gotta find radius first, which is here. Okay, both of them are radius, so you can find the radius first by doing Pythagorean theorem. R squared plus r squared equals 5 squared. So 2r squared equals 25. R squared is 25 over 2, so r is square root of that. Okay, you can get a number there. Why do I need radius? Because I need radius to find this. So I'm going to do big circle minus the triangle. Okay, minus the triangle. Okay, so the big circle is going to be pi r squared, which is this square, minus this triangle, right? Well, this triangle in reality really is just a square, right? Because you have half of this plus half of this, so it will be r squared. It's basically 1/2 base times height. Base is 2r, right? Base 2, like that. You can do it like that, or you can assume that these things just makes a square, so you can put this over here. So this will be the same as basically this square. Okay, and then you just subtract. Okay, and that will give you an answer. Okay, that's all 7 problems. How are we doing? I know it's a lot. Feel free to rewatch the video and ask clarifying questions if you will. But if you came up late, you can also drag the live video back to see the previous problems. Okay. Well, until next time then. See ya.